students, welcome to the module on acids and bases. In this module, you are going to study about different concepts of acids and bases. We are very much familiar about the term acid and base. I think you all know some of examples of these acids and bases. Acids, bases and salts have an impact on chemistry as well as our daily life. Acids have a sour taste. The word acid comes from the Latin word acer, which means sour, and bases have a bitter taste. Citric acid is found in fruits such as oranges and lemon. Tartaric acid you can see in tamarind. Malic acid in apples and lactic acid in milk and milk product. As well as you heard about hydrochloric acid in gastric fluids. Many bases such as lime water, washing soda can also be found in our everyday life. So, how we can identify a substance as an acid or base? For this, you have to study about the different concepts of acid and bases put forward by different scientists. First, we shall study about one of the famous concepts put forward by Arrhenius, and the concept is known as Arrhenius concept of acid and base. Before coming to the Arrhenius concept, first you have to write some examples of familiar acids. Please write. I think you may be listed the following acids such as hydrochloric acid HCl, sulfuric acid H2SO4, H3PO4 phosphoric acid, HNO3 nitric acid. Now, can you identify the common ion present in it? Yes, it is H plus ion. Students, please you write some common examples of bases. Yes, they may be sodium hydroxide, NaOH, potassium hydroxide, KOH, ammonium hydroxide, NH4OH. As in the previous case, can you find out the common ion or radical in it? Yes, it is OH minus ion. Based on this observation, you can formulate the concept of acid and base. According to Arrhenius concepts, acids are the substance which donate H plus ion in aqueous solution, and bases are the substance which donate OH minus ions in the aqueous solution. So, this is the concept proposed by Arrhenius. Now, we shall write the dissociation equation for HCl acid. HCl plus H2O gives H3O plus plus Cl minus. Here what happens to HCl? HCl release one H plus ion. So, it behaves as an Arrhenius acid. A bare proton H plus is very reactive and cannot exist freely in aqueous solution. Thus, it bonds to oxygen atom of solvent water to give a trigonal pyramidal hydronium ion, that is H3O plus. It is a hydrated proton. Similarly, a base molecule like MOH ionizes in aqueous solution. According to the equation, MOH gives M plus plus OH minus. The hydroxyl ion also exists in the hydrated form in aqueous solution. So, in short, Arrhenius acids donate H plus ions in aqueous solution and Arrhenius base donate OH minus ions in aqueous solution. Now we can find out some limitations of this definition. It can explain the acidity or basicity of a substance only in aqueous solution, and it does not account for the basicity of certain substances like ammonia, which does not possess a hydroxyl group. These are the limitations of Arrhenius concept. Now we shall discuss the second concept, that is Bronsted-Lowry concept. Let us start our discussion from the limitation of Arrhenius concept. We found that Arrhenius concept cannot explain the basic nature of ammonia. So now we can write the equation that explains the basic nature of ammonia. Ammonia is represented as NH3, and the equation is NH3 in aqueous solution, that is plus H2O liquid, gives NH4 plus OH minus. You can see the slide. Here in the slide, it is marked as NH3 as base, H2O as acid. On the product side, you can see that NH4 plus as conjugate acid and OH minus as conjugate base. So from the equation, it is very clear that NH3 acts as a base. How it can act as a base? It can act as a base by accepting an H plus ion. From where it gets H plus ion? Yes, it is obtained from the H2O molecule. So according to Bronsted-Lowry concept of acid and base, acids are the substance which donate H plus ions, and bases are the substance which are capable of accepting the H plus ion. In short, acids are proton donors and bases are substance which accept protons. We shall consider the equation for dissolution of ammonia in water once again. See the equation. Here you can see that two acids and bases, that is NH3 as base and the H2O as acid on the reactant side or left side, and NH4 plus and OH minus as acid and base on the product side. Now you compare NH3 and NH4 plus. One is base and the other one is acid. We can say that NH3 becomes base by accepting H plus ion to form NH4 plus, and NH4 plus is the conjugate acid of the base NH3. So we can say that NH3 and NH4 plus are conjugate acid base pair. Similarly, consider H2O and OH minus. H2O is acid and OH minus is the base formed from the acid. So OH minus is called conjugate base of the acid H2O. Therefore, H2O and OH minus becomes conjugate acid base pair. So a conjugate acid base pair differ in one H plus ion, and the addition of H plus ion leads to the formation of a conjugate acid, or removal of H plus ion leads to the formation of a conjugate base. So they differ in H plus ion. Now we shall consider two reactions, that is dissolution of ammonia in water and dissolution of HCl in water. See the equation in the slide. What is the peculiarity of this reaction? What is the importance or peculiarity of H2O? In the first reaction, that means dissolution of ammonia in water, H2O acts as acid. And in the second reaction, dissolution of HCl in H2O, H2O acts as a base. So here water play a dual role. That is, in the first case it is an acid, and in the second case it acts as a base. Such substances which can act as both acid and base are called amphoteric substances. Now we shall discuss the third concept of acid and base, that is Lewis concept. G. N. Lewis in 1923 defined acid as a species which accept electron pair and base which donate an electron pair. We know that as far as the base concerned, there is not much difference between Bronsted-Lowry concept and Lewis concept. As in both cases, you can see that the base provide a lone pair. However, in Lewis concept can be applicable to acids that do not have proton. A typical example of this type of reaction is the reaction between electron deficient BF3 and electron rich NH3. BF3 does not have a proton, but still it acts as an acid. It reacts with NH3 by accepting its lone pair of electron. This reaction can be represented like this: BF3 plus NH3 gives BF3 NH3. So in short, we can say that electron deficient species can act as Lewis acid, and electron rich species or substance which can donate an electron pair can act as Lewis base. Substances like aluminum chloride, CO3 plus, Mg2 plus, etc. can act as Lewis acid, while species like H2O, NH3, OH minus, which can donate a pair of electron, can act as Lewis bases. So in this module, dear students, we learned about different concepts of acids: Arrhenius concept, Bronsted-Lowry concept, and Lewis concept. Hope you all understood about this concept. Thank you, students. Thank you. Meet in the next class.